A new kind of arms race is quietly unfolding, not with nuclear warheads or stealth bombers, but with circuits, servos, and artificial intelligence. The battleground is the future of warfare, and the soldiers are robots. We delve into a critical geopolitical development, the burgeoning dominance of China in the field of military robotics, a sector where innovation could tip the global balance of power. From the sprawling tech hubs of Shenzhen to the secretive defense labs in the United States, a fierce competition is underway. We'll examine the key players, the groundbreaking technology, and the profound ethical questions that arise as we march into an age of autonomous warfare. Is the world ready for a robot-led military? And what does it mean that one nation appears to be winning this race? This is the story of the new robot war. The ascent of China's robotics industry has been nothing short of meteoric, driven by a national strategy that fuses commercial innovation with military ambition. At the forefront of this charge are companies that might not be household names in the West, but are titans within the industry, commanding immense resources and state support. One such giant is Unitree Robotics, based in Hangzhou. While publicly known for its quadrupedal robots like the Go-1, which has been dubbed the robot dog and marketed for civilian use, its technology has clear military applications. These robots demonstrate advanced mobility, capable of navigating complex and unstructured terrains, from rubble-strewn urban environments to rugged mountain paths. Their ability to carry payloads, conduct surveillance with high-definition cameras, and operate in swarms makes them ideal candidates for reconnaissance, patrol, and even direct combat roles. The line between civilian and military tech is deliberately blurred, allowing for rapid development cycles fueled by the massive consumer market, with innovations quickly adapted for military use under China's military-civil fusion doctrine. Another key player is CloudMinds, a company specializing in cloud-based artificial intelligence for robots. While it has faced scrutiny and sanctions from the United States over concerns about its ties to the Chinese military, its core technology is central to the future of autonomous systems. CloudMinds aims to create a cloud brain, a vast, interconnected network of AI that can control a massive fleet of robots, allowing them to learn collectively and share information in real time. For a military context, this translates to an army of robots that can coordinate attacks, share battlefield intelligence instantly, and adapt to changing conditions without direct human intervention. The strategic advantage of such a system is immense, enabling a scale and speed of operations that a human-commanded force could never match. These companies, and many others like them, are not just building machines. They are building the ecosystem for a future automated army, backed by a government determined to achieve technological supremacy by any means necessary. On the other side of the Pacific, the United States, long considered the global leader in military technology, is racing to keep pace. The American approach has historically been driven by massive defense contractors and a sprawling research network spearheaded by agencies like the Defense Advanced Research Projects Agency, or DARPA. The most recognizable name in American military robotics is Boston Dynamics. Originally a spin-off from MIT, its journey through acquisitions by Google, SoftBank, and now Hyundai has been closely watched. Its robots, like the bipedal Atlas and the quadrupedal Spot, are marvels of engineering, showcasing unparalleled agility, balance, and dexterity. Atlas can perform parkour, and Spot can open doors and inspect hazardous sites. These capabilities have direct military relevance for tasks like explosive ordnance disposal, urban combat, and logistics. For years, viral videos of Boston Dynamics robots have served as a symbol of American ingenuity and its edge in advanced robotics. However, the American ecosystem faces different challenges and operates under a different philosophy. Unlike their Chinese counterparts, US companies like Boston Dynamics have often been hesitant to weaponize their platforms, focusing on logistics, support, and reconnaissance roles. This reflects a broader ethical debate within the American tech community and a more cautious approach from the Pentagon regarding autonomous weapons. Another key player is Ghost Robotics, which has taken a more direct approach to military applications. Their Vision 60 quadrupedal robot is explicitly designed for military and security operations, patrolling U.S. Air Force bases and being tested for a variety of defense roles. The key difference lies in the structure of the industry. The U.S. model relies on a competitive and sometimes fragmented landscape of private companies and government contracts, which can lead to slower integration compared to China's top-down, state-directed strategy. The race is not just about who can build the most advanced robot, but also about who can integrate it into their military doctrine faster and more effectively. While the US still holds a significant technological edge in many areas, the gap is closing rapidly, and the sheer scale and speed of China's development present a formidable challenge to America's long-held supremacy. The culmination of this technological race is the war robot, an autonomous or semi-autonomous system designed for direct combat. China has been particularly aggressive and transparent in showcasing its developments in this domain. State-run media frequently broadcasts footage of armed robot dogs participating in military drills, firing assault rifles from their backs. These demonstrations are not just for show, they are a clear signal of intent and capability. The Norinco Sharp Claw 1, an unmanned ground vehicle, is a tracked, tank-like drone that can be armed with a machine gun and used for reconnaissance or direct fire support. China is also developing swarm technology, where dozens or even hundreds of small, armed drones can coordinate to overwhelm an enemy's defenses. At the Zhuhai Air Show, China has repeatedly displayed concepts for loyal wingman drones and manned aerial vehicles controlled by AI that would fly alongside manned fighter jets, acting as decoys, sensor platforms, or weapon carriers. In contrast, the United States' development of armed robots has been more guarded, though no less serious. The U.S. Army's Robotic Combat Vehicle (RCV) program is a major initiative to develop a family of robotic tanks. Prototypes from companies like General Dynamics and BAE Systems are undergoing rigorous testing. These vehicles range from smaller, transportable robots for reconnaissance to larger, more heavily armed variants designed to fight alongside traditional tanks and infantry. The concept is to use these robots to make first contact with the enemy, saving human lives by sending machines into the most dangerous situations. The U.S. military is also heavily invested in autonomous aerial systems, from the well-known Reaper and Global Hawk drones to more classified programs. However, a significant policy and ethical line has been maintained. The decision to use lethal force must, for now, remain under meaningful human control. This contrasts with China's apparent willingness to explore greater autonomy in lethal decision-making, a distinction that could have profound implications for the speed and nature of future conflicts. The war robot is no longer science fiction. It is a tangible piece of military hardware at the center of a strategic competition between global powers. The proliferation of robotic warfare presents a complex web of pros and cons, fundamentally altering the calculus of conflict. The most significant advantage, universally cited by military planners, is the potential to save human lives. By sending robots into harm's way for dangerous missions, such as breaching fortified positions, disabling explosives, or performing reconnaissance in hostile territory, the risk to soldiers is dramatically reduced. This could lower the political and social costs of military engagement, making it easier for governments to act without fear of public backlash over casualties. Furthermore, robots possess capabilities that surpass human limitations. They can operate for extended periods without fatigue, process vast amounts of data in real time, and withstand environments that would be lethal to a human. A robotic soldier can have 360-degree vision, infrared sensors, and a level of precision and reaction time that no human can match. From a strategic perspective, autonomous systems enable a new scale and speed of warfare. Swarms of drones could execute complex, coordinated attacks on a scale that would be impossible to manage with human pilots, overwhelming even the most sophisticated air defense systems. However, the downsides are equally, if not more, profound. The most pressing concern is the ethical nightmare of lethal autonomous weapon systems, or LAWS machines that can independently select and engage targets without direct human supervision. This raises fundamental questions about accountability. If a robot makes a mistake and kills civilians, who is responsible? The commander, the programmer, the manufacturer? The lack of a clear chain of accountability could erode the laws of armed conflict. Another major risk is the danger of rapid, unintended escalation. Conflicts fought by autonomous systems operating at machine speed could spiral out of control in seconds, far faster than human diplomats or commanders could intervene. A bug in a targeting algorithm or a misinterpretation of sensor data could trigger a catastrophic chain reaction. Moreover, the barrier to entry for warfare could be lowered. If the human cost of conflict is removed, nations might become more inclined to use military force to resolve disputes. Finally, there is the risk of an arms race and proliferation. As this technology becomes cheaper and more widespread, it could fall into the hands of non-state actors, terrorist groups, or rogue nations, leading to global instability. The very technology designed to protect soldiers could ultimately make the world a far more dangerous and unpredictable place. Looking ahead, the future of robotics in warfare is poised to move from a supporting role to a central one, fundamentally reshaping military structures and doctrines. In the near term, we will see an increasing integration of human-machine teaming. Soldiers on the ground will be accompanied by robotic mules carrying their gear, small drones providing aerial surveillance, and robotic combat vehicles offering fire support. The human will remain in the loop, making the critical life or death decisions, but their effectiveness will be multiplied by the robotic systems at their command. This hybrid model seeks to leverage the strengths of both humans' creativity, ethical judgment, and adaptability and machine speed, endurance, and data processing power. Armies will be reorganized around these new capabilities, with new roles created for robot operators, AI supervisors, and data analysts, while traditional infantry roles may diminish. In the long term, the trend points towards greater autonomy. As artificial intelligence becomes more sophisticated and reliable, the temptation to grant machines more decision-making authority in fast-paced combat scenarios will grow. The concept of meaningful human control will be tested and stretched. The ultimate vision for some military strategists is a fully automated battle space, where networks of AI-controlled robots on the land, in the air, and at sea coordinate and execute military objectives with minimal human intervention. This future brings to life the science fiction scenarios many have feared. The competition between nations like the US and China will not just be about building better hardware, but about developing superior AI and more resilient command and control networks. The ethical guardrails that are being debated today will determine whether this future leads to a more stable world with fewer human casualties, or a terrifying new era of hyper-fast, uncontrollable machine-led warfare. The choices made in the next decade by policymakers, engineers, and citizens will determine the path we take. As the lines between soldier and machine continue to blur, the world stands at a precipice. The race for robotic supremacy, currently led by the rapid, state-driven advancements in China, is not merely a technological competition, it is a battle for the soul of future warfare. The promise of protecting human lives is powerful, but it is shadowed by the terrifying prospect of autonomous killing machines and a world where the decision to go to war is made easier. The questions we face are no longer theoretical. They demand urgent answers from our leaders, our scientists, and ourselves. How do we harness this incredible technology for good while preventing its darkest applications? As this new arms race accelerates, the fate of global security may well be decided not by the courage of soldiers, but by the code that governs the robots fighting in their place. The future is arriving faster than we think, and we must be prepared for the world it will create.